second. Okay. It says f is continuous on the closed interval. I don't always think that this is a very valuable clue, but in one of these true-false ones, it's usually essential. Okay, which of the following must be true? So all we know is f is continuous.
Yeah.
There is a number c in the interval. So c is an x coordinate. Comfortable?
Yeah.
Such that the y coordinate of f is 0. So basically they're saying if f is continuous, is it guaranteed that f will always equal 0?
Well, it depends on what A and B are, right?
It actually has nothing to do with a and b, because a and b are just x coordinates,
Uh-huh.
and then the function f somehow is between those two.
Yeah.
So is it guaranteed that this function f must have a y coordinate of 0?
No.
No. So that one does not have to be true.
Okay.
Good
Yeah.
there? And if April or Chloe need to jump in if you're listening, that's fine. If not, no worries. So if friends of Chloe want to jump in, you're welcome to. So they're giving me a look of like, what the? Okay. There is a number c in this interval such that the y coordinate at A will for sure be less than the y coordinate at C, for sure less than the y coordinate at B. Well, that would require a function f that maybe starts here, goes here, and then goes like here.
But it could just be horizontal.
Yeah, there's nothing that says f has to do that.
Yeah.
F just has to be continuous.
Uh-huh.
So that doesn't have to be true either.
Okay.
Okay?
Uh-huh.
There is a number c from A to B such that the y coordinate at that point is bigger or equal to all of the other y coordinates.
Oh, so that's what that X means. So that X just, so C is representing an X point from A to B, but that X is representing all the other X points?
Because it says here, for all x in A to B.
Okay.
That's well done. So f of c means a single y coordinate. So we've got our function f, and one of the y coordinates of f
Uh-huh.
is supposed to be higher than all the others,
Okay.
or equal to.
So when it says the closed and open interval, if it's a closed interval, does that mean C could be A or B? And then if it's the open interval, it can be A or B? Okay.
Correct.
So then in this case, C could be A, and in that case, it's smaller than all the other values.
This right here is actually what's known as the extreme value theorem. The theorem simply says if you have a function which is really just a bunch of dots, then yeah, one of the dots, like even if the function is a bunch of horizontal dots, is one of these dots, does one of these dots have a y coordinate that is greater than or equal to all the others?
Equal to all the other ones.
Yeah, so that's true then. If you have a graph that goes like this, is one of the dots greater than or equal to all the others?
Yeah.
Yeah.
So the trick with the extreme value theorem is it's greater than, but it also could be equal to the other one, not just greater than.
Correct. If it were just greater than, it wouldn't be the extreme value theorem. That wouldn't, like if they left off the equal sign, then this one does not have to be true any longer.
Yeah.
Because you could have a horizontal f,
Okay.
where that wouldn't be true. They could flip this around. It's still the extreme value theorem, because extreme value theorem coincides with min and max.
Yeah.
Good?
Okay.
So that's the answer. Let's keep going.
Yeah.
Very good. There is a number c such that, so they're saying you have a function f. Are you guaranteed that if this function f is continuous, somewhere the slope of f will be 0?
No.
No.
You don't know.
You don't know. F could just go up,
Yeah.
like so, and then there'd be no slope of 0.
Uh-huh.
Okay, E is the mean value theorem. The mean value theorem says,
You can't
if f is continuous and differentiable, then somewhere there will be a tangent slope of f that is equal to the secant slope of f.
Okay.
But because they did not declare f to be differentiable, this no longer has to be true.
Yeah.
So that's why it's false.
So then just a hypothetical question. If 82 had said that the function was continuous and differentiable, we know E would have been correct. But for C, could that have also been correct? And if it would have been, then they probably obviously wouldn't have put in both.
Correct. Yeah, if they, I'll say it back to you. If they declared f to be differentiable, then both item C and item E would have to be true.
Okay.
So they would have had to change the question in some way to prevent that.
Yeah.
Like an easy way would have been to make this just greater than.
Okay.
That would have been a really slick way to make it subtle,
Yeah.
but subtly not necessarily true.
Okay.
That
Yeah,
make sense?
that makes sense.
Good question. Good?
Yep.
Your turn, April.
77.